The next item, using special rules to integrate. We want to look at what's called the u method. If we have the integral of f of u du, where u is a function of x, and capital F of x has the property that its derivative is f of x, then since the f of u has a du here, it's kind of the reverse chain rule, then the integral of f of u du is equal to the integral of capital F of u plus c. Let's integrate this by looking down at example A. Since we don't have a convenient antiderivative or integral the sine of the square root of x, let us let u equal the square root of x, which is another way of saying x to the 1/2. If we find du, we'll take 1/2 x to the negative 1/2, or x to the 1/2 in the denominator. Now, what we want to do is take the original integral and rewrite it in terms of u. So you will notice here that we have a dx, we have the square root of x here. So if we rewrite this, we're left with 1/2 the integral, the sine of u du. Because here, every place we have the square root of x, we're going to replace it with a u. But this is a simple integral to do. The integral of the sine is negative the cosine of u. Now the last thing we need to do is go back to the u values, replace it with what do we substitute it for. So our answer here would be negative 1/2 cosine the square root of x plus c. A second strategy is what's called change variable. If we have u is equal to g of x, has a derivative everywhere in the closed interval, and f is continuous in the range of g, so we have the composition of functions. So we take the integral from a to b, these are x values, of f of g of x, g prime of x. It's going to have the same result of the integral of f of u du, g of a, g of b. These are the g values. So let's look at an application here. If we want to integrate from 0 to 2, notice each of these are x values. And if we wanted to solve this, notice if we let u take on the value of x cubed plus 1, conveniently du is 3x squared dx. And notice the x squared dx is exactly the same as what we're working with here. So if we were going to solve for x squared dx, we would replace x squared dx here with du divided by 3. So let's change these from x's over to u's. Now x cubed plus 1 is replaced with u, so we have u to the 1/2. Here we have du over 3. We can put the 1/3 out in front. So that's all we have to do to integrate this. So we have 1/3. We add 1 to 1/2, 3/2, divided by 3/2, where that's the same as times 2/3. So we're left with 2/9 u to the 3/2 plus c. We don't need the c because we're doing definite integrals. Now we could switch this back to x's like we did in the previous example. However, an alternative method is that let's take our u values. Let's see, u is equal to x cubed plus 1. Our lower limit was x equal to 0. So if we replace 0, we wind up with a lower u value of 1. Our upper x value is 2. So if we replace x with 2, 2 cubed is 8 plus 1 is 9. So now if we evaluate this answer, 2/9 u to the 3/2 from 1 to 9, we wind up with 2/9 times 9 to the 3/2 minus 1 to the 3/2. 9 to the 3/2 is the square root of 9, which is 3 cubed, so that would be 27. Minus the square root of 1 is 1, cubed is 1. So we're left with 2/9 times 26, which gives us 52 over 9.